this video, we show some examples how to compute for the initial conditions of RC and RL circuits. In this example, we have a network containing a capacitor and a switch that has been in position A for a long time. So that means that the circuit is or has attained a steady state condition before transferred to position B. So the act of flipping the switch from A to B disturbs the circuit and will trigger a transient condition, especially the part that contains the capacitor. So the question here is what is the voltage of the capacitor when the switch is at position A? So meaning while the circuit is at steady state uh, prior to the transfer of the switch. The instant the switch is transferred to B and the voltage just after the switch transfers to B. So we are required to get the voltage V uh, at or before t equals 0, the voltage at exactly t equals 0, and the voltage just after t equals 0. We are also required to know the current through the capacitor at the instant the switch is transferred to B. So meaning what is I through the capacitor at t equals 0. Here I have redrawn that part of the circuit that includes the capacitor. The part containing the 30 volts is not shown since that part is disconnected. The capacitor is drawn as an open circuit because this circuit here is in steady state, and therefore the capacitor is acting like an open circuit where the current is 0 and the voltage is a constant. To get the voltage of the capacitor at steady state, we notice that it is equal to the voltage across the 5 kilo ohm resistance. So therefore, the voltage of the capacitor just before t equals 0 can be computed as the voltage divider across the 5 kilo ohms. So that would be 24 times a factor, which is 5 kilo ohms divided by 5 plus 3. And that should give us 15 volts. Let us also include the current. So here this should be 0 amperes. After the switch is transferred to position B, this is now our circuit. We didn't include that part of the circuit containing the other voltage source, although that circuit is active because it is a closed circuit. But since we're only concerned of the parameters involving the capacitor, we only focus on this part of the circuit. So the question now is, what is the voltage of the capacitor at t equals 0 and the current? Let's say this is the current here. So we try to get the current that is in that direction. So what is the current also at t equals 0? Now take note that the voltage cannot change instantly. So the 15 volts that it possessed before the transfer of the switch is still 15 volts at t equals 0. So therefore, the voltage at t equals 0 is also 15 volts. For the current, we can apply KVL around the loop. So for example, for the current, we can apply KVL around the loop. So the voltage across the 4K it is positive here and negative there. So writing the KVL starting here, that would give us a negative V at t equals 0 minus 4000 I plus 30 volts equals 0. Now this voltage is 15 volts. So take note, I here is at t equals 0. Okay, so this is at t equals 0. And that should give us an I that is equals to 3.75 milliamps. If we are to plot the voltage and current to the capacitor, that would give us something like this. Okay, so let's say this is our axis and this is time here. So for the voltage uh, at steady state, it is 15 volts. So this is 15. And then at t equals 0, it is still 15. And after that, it could either go up, go down, depending on the values of the capacitor, the capacitance of the capacitor, the and the resistance here. For the current, it started 0 and then it jumps at t equals 0. So let's say it jumps at 3.75 milliamperes. So let's assume this to be our voltage here, and this will be our uh, current here. Okay, so this is 3.75 milliamps, um, and the voltage is 15 volts. As time increases, the circuit will go to a transient condition. So again, as I've said, the voltage could either go up or go down. Likewise, for the current, it could either go up or go down. But eventually, those values will again settle to a new steady state values. But for this problem, we're just interested for the initial conditions. And those are the voltage at t equals 0, the current at t equals 0. Take note that the voltage across the capacitor just after the switch is transferred to B is still 15 volts. Okay, and the current also at just after t equals 0 is also 3.75 milliamps. Okay, in this example, we have again a network that contains a capacitor. Here we are asked to determine the current through the capacitor at t equals 0. So let's assume the current to be I sub C through the capacitor. Take note that this switch is closed before t equals 0 and the circuit is at steady state prior to the opening of the switch. This is our circuit diagram before the switch is open. Since the circuit is at steady state, we draw the capacitor like an open circuit. So the current through our the capacitor is zero at steady state. So therefore, we can say that our current through the capacitor before t equals zero is zero, while the voltage at or before t equals zero is, well, the capacitor is directly in parallel with this voltage, therefore we can say that this is equals to 10 volts. At t equals 0, the switch opens and the voltage in the capacitor is still 10 at that point in time. Um, so therefore, the question now is, what is this one? Okay. Take note that the current through the 20 ohms is the voltage across that resistance, which is also 10 volts because it is connected parallel to the capacitor. So therefore, this current must be 10 divided by 20. So this is 0.5 amperes. To get I sub C0, so the current through the capacitor at equals 0, um, I can apply KCL here, which means that I sub C at equals 0 must be equals to I minus 0.5. To get I can write KVL around this loop. So starting here, that would give me negative 30 plus 10I plus 10 volts equals 0. So I there would be 20 divided by 10 or equals to 2 amperes. Okay, so therefore I sub c at equals 0 becomes 2 minus zero point 0.5 or 1.5 amperes. So this is our answer for the current through the capacitor at t equals 0. If we try to plot the current versus time, so this is the current through the capacitor. So before t equals 0, the current is 0, and at t equals 0, it jumps to 1.5, and then from there the circuit undergoes a transient condition. So therefore, the current through the capacitor could either increase or decrease, but will settle to a new steady state value.